This is the 6-1 to 6-3 review. Calculators are not allowed, and it's 5B. And again, I'm going to do this both methods. So we'll see one with washers, and we'll see it again with cylindrical shells. So for both of these, we need to graph the axes and the region that's being rotated. So in this case, it is a parabola that opens down and has a vertex at 2, 1. So it will intersect the x-axis at 1, 0 and at 3, 0, and the vertex up here looks like it is 2, 1. So here's the region, and we're rotating around the line y equals, or x equals 0. And the first thing we're going to do is cut horizontally so that we will create washers. So when we create those washers, we're going to need to label the point on the axis of rotation and then the 2 points creating the strip. All of these points have a y in common. So this one we can label as 0, y. These two are going to come from this expression if I isolate the x. So if I isolate the x, the first thing I'd do is move the 1. Then I would change the sign. Then I would take the square root. And then I would add 2. So that's my x. So I can see that on the right side of the parabola I'm going to have the positive root. So this one's going to be 2 plus that root of 1 minus y, comma y. And this one here will be 2 minus the root, comma y. So our goal is to find the big radius and the little radius so that we can set up our integral. So the big radius is going to be this rightmost x-coordinate minus this x-coordinate. So we'll get a 2 plus square root of 1 minus y. And the little radius will be this middle coordinate, the x-coordinate minus the x-coordinate of the axes. So my little radius is going to be 2 minus that root. So when I set up my, remember thickness here is dy. When I set up my volume integral, it will be pi times the accumulation from the lowest y value to the highest y value, so that's from 0 to 1, of that big radius squared minus the little radius squared. Now we don't have a calculator, so that means we're going to have to multiply all this out and then compute the integral by hand. So first, if I multiply this out, when I square the binomial, I have a 4 plus 4 of those roots plus that root. Oops, that's a minus. And then I'm going to subtract this one multiplied out, which will be 4 minus 4 of those roots plus that 1 minus y again. So when I subtract, the 4's will cancel, the 1 minus y's will cancel, and I'll be left with 4 of these roots plus 4 more of those roots. So I'll have a pi times the accumulation from 0 to 1 of 8 of those roots. So in order to evaluate this, I need to do a substitution method, which will end up being having a u that's a 1 minus y. So a dy will be that du over a negative 1. And when I substitute, I'll pull that 8 out in front. I'll have a root u, which is a u to the 1/2. And then I'll have a dy, which is a du over a negative 1. So now let's look at what the limits would be. If I plug 0 into here, I'll get 1 on the bottom, and 1 into here, I get 0 on the top. Well, that one's kind of going backwards, so I can switch those limits and change the sign in front. And now I'm ready to do the antiderivative. So what did I take the derivative of with respect to u that gave me u to the 1/2? That is u to the 3/2 divided by 3/2, which is the same as 2/3. I evaluate from 0 to 1, plug the 1 in first. I'm going to end up with a 16 pi over 3 minus plugging the 0 in gives me 0. So that's doing it with the washer method. Now if I want to do this again using the cylindrical shell method, then I would have the same region, except now I'm going to cut vertically. And when I cut vertically, I'll label with x's. So this will be x comma 0, and the top one will be x comma the opposite of x minus 2 squared plus 1. So when I rotate that now, I'm going to be rotating around my blue y-axis here. So that means I'm going to need a point on the y-axis so that I can compute that radius. So when I rotate that around, we can see that the height is this y-coordinate minus this y-coordinate. And I can see that the radius is this x minus 0. So I can now set up my volume, which will be 2 pi this time, times the radius times the height times dx, and we're looking at the x limits, so we'll go from 1 to 3. So if I multiply that out so that I can actually compute it, I have a 2 pi integral from 1 to 3, and I'll have an x. I'm not going to try and distribute at the same time that I'm multiplying out here, so this is going to give me an x squared negative. The middle terms will give me a negative 4x, so that'd be a positive 4x. The outsides would give me a positive 4, that's a negative 4, plus a 1 gives me a negative 3. So now if I distribute that x through, I'll have a negative x cubed plus a 4x squared minus a 3x with respect to x. So now I'm ready to do the antiderivative. Antiderivative is going to give me a negative x to the 4th over 4 plus a 4x cubed over 3 minus a 3x squared over 2, and that gets evaluated from 1 to 3. So if I plug the 3 in, I have a negative 81/4 plus, I have a 3 cubed over a 3, so that's a 3 squared, which is a 9 times 4. And then I have a 9 times a 3 is a 27 over 2. So there's plugging in the 3. Now I need to subtract what I get when I plug in the 1. So the 1's going to give me a negative 1/4 and a positive 4/3 and a negative 3/2. So I'm going to try and connect the things that have the same denominators and see if things will reduce. I have a negative 81/4 plus a 1/4, so that's going to give me a negative 80/4, which is a negative 20. And I have a 36, which isn't too bad. And then I have a negative 27/2 minus a negative 3. So that means I'm going to add 3. That'll be a negative 24/2, which is a negative 12. The only thing I haven't done yet is this 4/3. So let's combine this stuff together first. I get a negative 32 plus a 36. Well, that is a 4 plus a 4/3. Oh, sorry, this is a minus 4/3. That makes more sense. Sorry, guys. 2 pi times, there's my 12 minus my 4 all over 3. So I have a 12 minus 4 is an 8 times a 2. There we go. We get the 16 pi over 3.